Assalamualaikum. Today, what we are going to do, class 9, subject physics, chapter number 5, we are doing already. Topic chapter number 5, as we were doing already. Topic of today lectures are 5.2 topic and 5.3. These two topics are on page number 110, 111, and 112. We will do the example as well on this page, which is on page number 111. So these two topics, 5.2 topic and 5.3 topic today we will do. Pages covered of this today's lecture is 110, 111 and 110. Please open your ninth class textbook. Thank you. So again, I'm going to tell you unit number 5, gravitation. This chapter we are studying. So I'm moving toward my topic. Topic of today's lecture is 5.2, which is in front of you, mass of the earth. This topic we are going to do 5.2, mass of the earth. So this is on page number 110. If you open your ninth class textbook, you will find this topic 5.2, mass of the earth. Consider a body of mass m on the surface of the earth as shown in the figure 5.4. This is 5.4 figure. Weight of the body is equal to the gravitational force between the body and the earth. So you know this is the mass which is lying on the surface. This is the earth. Blue color, blue one is earth, and this is a small body of mass m which is lying on the surface of the earth. So its mass is denoted with small m, and while the mass of the earth is denoted with ME, capital ME. E stands for mass of the earth, and the distance between the center of the earth to the body is denoted with the radius. This is called radius or capital R. Since the body is lying on the surface of the earth, that's why this is taken as the radius. The radius of the earth is taken as the, because the body is lying on the surface of the earth, and the weight of the body is acting downward. You know the as we already defined the definition, define the weight definition. So weight is the force with which the force acts, with which the earth attracts the body towards its center. So since the body is lying on the surface of the earth, it is not at some height, so its distance is capital R. So again, I repeat, mass of the body is denoted with small m, and mass of the earth is denoted with capital ME, and R is the distance between center of the earth to the body. So since the body is lying on the surface of the earth, so its distance will be capital R, where R is the radius of the earth. Okay, so I write the definition because we have already studied definition of the law of gravitation. So I'm going to write the law of gravitation in this case. So when we studied, if you open the page number 107, you will find the gravitational force F equals to G m1 m2 d square. This is the definition of the law of gravitation. So in this case, because our there are the two bodies, same bodies, but the mass here, the body, one body is Earth and the other body is M. So I will write the formula or write the force of attraction between these two bodies, and the distance between them is capital R. So F is equal to G M M E divided by R square will be my law of gravitation for figure 5.4. So you know for force F is equal to W and W is equal to mg. This formula, you know, weight formula, W is equal to mg. So F is equal to W and W is equal to mg is the weight formula. So I am substituting F is equal to mg in equation number 5.3. So my 5.3 equation becomes here mg. I'm putting F is equal to mg. mg equals to g me divided by r square. This m will cancel with this m because here it is multiply. If you take this down, this will be divided. So m will be cancelled with this m. The what is left then g is equal to capital G me divided by r square. You know, we have already studied capital G is the universal gravitational constant, and its value is 6.673 into 10 raised to the power minus 11. As we have already discussed, a law or universal gravitational constant, and universal gravitational constant is denoted with the letter capital G. So G equals to G me divided by r square. So in order to separate out me, where m is the mass of the earth, so what I will do, because r is divided, if it goes this side, it will be multiplied. And g is multiplied if it go on this side, so it will be divided. So you need to separate out mass of the earth. So what will you do by cross multiplying? You can separate out me, where me is the mass of the earth. In order to find the mass of the earth, what will I do? I will just plug in the values. Capital R, radius of earth, you know this is understood value, and the capital G, small g value, you know 10 meter per second square, and capital G value is 6.673 into 10 to the power minus 11. These all values are known to me, and these all values are understood. These all values are known to me, and these are understood. R is the radius of the earth, which is the fixed value. Capital G is also the fixed value, which is 10 meter per second square. And in the last topic, when I was studying law of gravitation, I told you the capital G value is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. So if you put all these values, radius of earth is fixed value 6.4 into 10 raised to the power 6 meter whole square multiplied by value of small g is 10 meter per second square. You already know, and I told you when we discussed law of gravitation. So the capital G value is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. So if we solve this, we will get mass of Earth, which is 6 into 10 to the power 24 kilogram. You know the mass unit of mass is kilogram. That's why this is the mass of the Earth. The mass of the Earth we calculate from this formula by plugging the values of radius of the Earth, the value acceleration due to gravity, and gravitational constant, as we discussed in law of gravitation when we studied the law of gravitation. We plug in all these values and we got the mass of the earth, which is 6 into 10 to the power 24 kilogram. So from now you got to remember this, mass of the earth is 6 into 10 to the power 24. This is also known to you now. So whenever this is not given to you in the numerical, you should memorize this by heart. Mass of the earth is 6 into 10 to the power 24 kilogram. You should know this all the time. As you know, value of small g is 10 meter per second square, and capital G is which is universal constant, which is 6.673 times power 10 power minus 11 Newton meter square, and radius of Earth is 6.4 into 10 power 6 meter. So these are all the values you should know by heart, because they will use in the numerical. So student, I hope you understand mass of the earth. If, you can ask me if you have any problem regarding mass of the earth, how we calculate the mass of the earth, you can ask me. So feel free to ask me at the end of the lecture. So I'm moving towards 5.3 topic, variation of G with O altitude. What is 5.3? I'm reading, this is a new topic I'm going to start. 5.3, variation of G with altitude. This is also on page number 110. I read it first and then I'll explain you. Equation 5.6 shows that the value of acceleration due to gravity G depends on the radius of the Earth at its surface. The value of g is inversely proportional to the square of the distance from the center of the Earth, but it does not remain constant. It decreases with altitude. Altitude is the height of an object or place above sea level. The value of g is greater at sea level than at the hills. Consider a body of mass m at an altitude h as shown in figure 5.5. The distance of the body from the center of the earth becomes r plus h. Therefore, using equation 5.6, we get gh is equal to g capital G me divided by r plus h whole square. So I'm going to explain you this. Look, in the last scenario, 110 page. So here the body is lying at the center, at the at the surface of the earth. But if you consider other figure, which is 5.5 figure, the body is not lying at the surface of the earth, but it is at a height of small height of h. This is not now at the surface of the earth. So, but the formula will be changed. The acceleration due to gravity is also depending. So in this figure, you got to remember this. Our body mass m is not lying at the surface of the earth. It is some at some height, which is the height is h, and the weight of the body is acting downward, and you know the formula for weight is mg. W is equal to mg, and me again the mass of the earth, and r is the radius of the earth. And since this body is at some height, so our h will be added with r. So now I'm going to do. I'm going to explain as we go up and up from the surface of the earth, the value of g decreases. You know, the value of g is depending. In the last example, if I show you this formula, g is equal to g me our r square. In this case, acceleration due to gravity g is depending upon the radius, the distance. So the square of the distance between this is the square of the distance. So this is, since r is divided, so that's why g and the relation between g and r is inversely proportional. Which means the radius, the more the distance, the more if we go up and up, the value of g decreases. But if we go down, the value of g increases. But if we go up, the value of g, the acceleration due to gravity, decreases. So value of g is at the sea level is different as compared to the value of g at the hill. It means if we go up, the value of g decrease. If we go down, the value of g increases. So at the surface of that, the value of g, you know, which is 10 meters per second square. But as we go up and up, the value of g decreases. Uh, that's why he's saying the value of g is inversely proportional to the square of the distance from the center of the earth, as I have already told you. But it does not remain constant. It decreases with altitude. As we go up, its value decreases. As we go up and up, its value decreases. Altitude is the height of an object or place above the sea level. The value of g is greater at sea level than at the hill. Obviously, if we at a sea level, the value of g is greater. If but as compared to the value of g decreases at the hills. So so this body is lying at some height h from the surface of the earth. So our 5.5 equation will become like this: gh is equal to capital G me r plus h. But if you look at this, so here there is no h, because the body mass m is lying on the surface of the earth. But as we are moving upward, this equation 5.6 will change. Uh, this equation 5.6 will change into this, because the body is not lying on the surface of the earth, but it is at some height h. That's why r will be added. In r we will add h, because the body is lying at some height h. So G over GH will be G. Therefore, I am writing H because the body is not at the surface of the earth. As if we go back here, I didn't write H because the body mass M is lying on the surface of the earth. But in this case, this mass is at some height h. That's why the equation 5.5 will change into gh is equal to gmer plus h whole square. According to the above equation, we come to know that at the height equal to 1 earth radius, if this height is equal to 1 earth radius, the distance from this to this is radius. So if we take this height same as radius, the value of g will become 1/4. But double if we double this height as radius, so it means height is double the radius, then value of g will become 1/9. You will see shortly in the numericals why what I'm saying. According to the above equation, we come to know that at a height equal to 1 earth radius above surface of the earth, the g becomes 1/4 of its value on the earth. The value of the on the earth is 10 meter per second square, you know this. But if we take the height at 1 earth radius, the value of g will be 1/4. But what will happen if we double the height as compared to the radius? Double the radius height. If you come the height double the radius, then the value of g will be 1/9. This is the end of the topic 5.3, variation of G with altitude. You should remember one thing very clearly: as we go up, the value of G decreases. The value of G is greater at sea level, but the value of G is less because at hills. So you should very much clear the value of G is decreases as we go up and up. So this is the end of the topic 5.3, variation of G with altitude. Now we solve the example 5.2. I read the numerical example statement, which is on page number 111. Calculate the value of G, the acceleration due to gravity at an altitude 1000 kilometers. The mass of the earth is 6 into 10 power 24. If it is not given, you should know that we just calculated mass of the earth, which is 6 into 10 power 24 in last. When we discussed, so this is the mass of the earth. You should know we just calculated in our last topic when we did mass of the earth. The mass of the earth is 6 into 10 power 24 kilogram. In this example, it is given to us. So calculate the value of g, the acceleration due to gravity. G is what? G is the acceleration due to gravity. At an altitude means it is lying at height 1000 kilometers. The mass of the earth is, you should know this by heart, 6 into 10 power 24 kilogram. The radius of the earth is given to you is 6400 kilometer. Kilometer. As as we discussed, radius of the earth as well. Look, 6.4 into 10 power 6 meter per meter. This is the radius of the earth. He has written this in kilometer, so 6400 kilometer. He has written this, right? So if you convert this into meter, what will do 3 10 power 3 or 10 power 3? This will be 6.4 into 10 power 6 meter. So you know radius of the earth is 6400 kilometers. Since the height of the mass is lying at the height 1000 kilometers, so mass of the earth is also given to me, which is 6 into 10 power 24. This is also given to me, and acceleration due to gravity we need to find out in this example. So since the body is not lying at the surface of the earth, but it is at a height of 1000 kilometers, so this 6400 is the radius of the earth will be added to the 1000. So r plus h will be 7400 kilometer. So if you convert this into meter, because the distance, the unit of Unit of a distance is meter. SI unit of the distance is meter. That's why I'm converting this into SI unit, meter. So you know kilo means 1000. So 100 multiplied by 1000 is 10 to the power 6. 7.4 into 10 to the power 6 meter. This we have converted into SI unit. The distance SI unit is meter. So now I will, since I want to find out the value of G at a height, 1000 kilometer acceleration due to gravity. So I will write the formula, same formula which we derived in 5.8 equation 5.8. This 5.8 equation is on page number 111. So I'm now just substituting the values. You know the acceleration gravitational constant value is, as we have already discussed when we discussed law of gravitation. Its value is 6.673 into 10 to the power minus 11. Again, mass of the earth is, we just found, we just calculated mass of the earth is in last topic. When we discussed mass of the earth, we calculated mass of the earth is 6 into 10 to the power 24. I'm just putting the value 6 into 10 to the power 24 out. And you know r plus h, the value of r plus h is 7.4 into 10 to the power 6. Take the square 7.4 into 10 to the power 6 meter whole square. So how will you do? How will you calculate this, student? What you need to do, when there is a multiplication sign, then the power will be added. So 24 times power 24 plus 10 to the power minus 11, they will be added. So you solve 6.673 in multiply 6.673 multiply by 6, and then solve separately 10 to the power 24 and 10 to the power minus 11. What you got to do, 7.4, you will take the square of 7.4, and 10 to the power 6 is 12. So after 10 to the power 6 is 12. So 10 to the power 6 square is 12. If you take this on and solve this, you will get 7.3, which is the 7.3 Newton per kilogram. So 7.3 meter per second square is the value of G at a height when the body is at a height of 1000 kilometers. You should know when, as I have already told you, as the body is going up and up, the value of G decreases. I have already told you the value of G decreases as the body go and up and up. So on the surface of the earth, everyone knows the value of the G is 10 meter per second square, because we are away from the surface of the earth and we are going at a height. So value of G, you can see the value of G is decreasing. On the surface of earth, its value is 10 meter per second square. But in this case, since the body is at 100 kilometers away from that, so surface of that, so its value is decreasing 7.3 meter per second square. So this is the end of the numerical. Thus the value of G, the acceleration due to gravity at an altitude at a height of 1000 kilometer is 7.3, because we are moving away from that, or we are going up and up, the value of G will decrease, as we discussed in our topic, value variation of G with altitude. So this is, you could see the value of G is also decreasing. So this is the end of the topic 5.3. These two topics were, this was our target to complete this 5.2 and 5.3. So this is the end of the topic 5.3. So I repeat the all things for you now. Now, student, what we did today, class 9th, subject physics, chapter number 5 we discussed, and topic of today's lecture was 5.2 and 5.3. These two topics are on page number 110, 111, and 112. So chapter number 5 we did today. We are doing chapter number 5. So this chapter name is gravitation. So we did today 5.2, mass of the earth. So this is the blue color is the mass of the earth. This is earth, and small m mass is lying on the surface of the earth. When there is a no distance, the body is lying on the surface of the earth. So mass is but the body is denoted with small m, and the mass of the earth is denoted with m, capital ME. The distance between the mass of the earth and the body is capital R. So I write the law of gravitation in terms of these two figures. Body small m, so I will write m. Capital G will be the same, which is the gravitational constant, and me is the mass of the earth. So r is the distance between these two. So my law of gravitation will become F is equal to G m me divided by r. Now we know that F is equal to W and W is equal to mg. So I will substitute mg, F is equal to mg in the equation number 5.3. If I put F is equal to mg, so the other side G is equal to G me over r square. This m will cancel with this m. So what is left? G is equal to G me over r square. So mass of the earth is equal to r square. If we separate out mass of the earth by cross multiplying, here r is multiplied, divide. If it is go on the other side, it will be multiplied. G is multiplying here. If it is go on the other side of the equation, it will be divide. So mass of the earth is separate out, r square times G divided by capital G. Mass of the earth can be determined. How can we determine? We know the radius of the earth, which is understood. You should know this by heart. 6.4 into 10 power 6. The value of radius of the earth is 6.4 into 10 power 6, and the value of the acceleration due to gravity is 10. So we discussed capital G, universal gravitational constant. Its value is 6.673 into 10 power minus 11. If you solve this with the help of calculator, you will find that mass of Earth is 6 into 10 to the power 24 kilogram. This is the mass of the Earth. So mass of the Earth is 6 into 10 to the power 24 kilogram. Since this is positive some value, it means there will be the 24 zero come with 6 and then 24 zero. So it means the mass of the Earth is very, very high, or mass of the Earth is very, very big. So then these two values, you should from now, you should memorize these values: radius of the Earth, value of G, which is 10 meter per second square, and gravitational constant value 6.673 into 10 to the power minus 11, and mass of the Earth. You should memorize this by heart: 6 into 10 to the power 24 kilograms. From now, you should memorize this, because these four radius of the Earth, acceleration due to gravity, and capital G, and mass of the Earth, you should know these values by heart from now, because they will use when we do the problem of this chapter. We should know these values by heart. Thank you. 5.3, then I'm going to start a variation of G with altitude. What it says, this topic says that as we go up and up, the value of acceleration due to gravity decreases. It means the more value of G is depending upon the altitude. More the altitude, the lesser will be the value of G. Lesser the altitude, more will be the value of acceleration due to gravity. But if I go back, and in this case, the figure 5.4, you know the mass is lying on the surface of the Earth. So our law of gravitation becomes like this: F is equal to G me over r square, because there is no the body is lying, mass body is lying on the surface of Earth, and there is no height exists. But in this case, in figure 5.5, the mass is lying at some height. It is not lying at the surface of the Earth. It is lying at some height, which is denoted with h. So our law of gravitation will become G is equal to G me r plus h. Because I am putting like this value, because this body is lying at some height h. That's why I am putting in G value, G is equal to G me over r square. This was I'm just putting h, because in this figure the equation is same, because in this figure the body is lying at no height. The body is lying at the surface of the Earth. But as we go up, But in this case, the body is lying at some height. That's why the 5.5 equation will becomes GH is equal to GMER plus H whole square. You know, as we go up, the value of G acceleration due to gravity reduces as and the value of G is greater at the sea level than at the hills. So the value of G, the acceleration due to gravity is bigger at sea level and then at the hills. And if we go at the hills, the value of G will be decreases. So value of G is decreases as we go up and up. According to the above equation, we come to know that height equal to one Earth radius. This height is equal to this radius. If we keep this height, if we keep the mass over here equals to one Earth radius, the value becomes 1/4. The acceleration due to the gravity will become 1/4. But what will happen if we double this value? If we keep this radius two times, the value of G will become 1/9. Now, this is the end of the topic 5.3, variation of G at altitude. Now we discuss example 5.2. I read the example 5.2 for you. Calculate the value of G, the acceleration due to gravity at an altitude 1000 kilometers. The mass of the Earth is 6 into 10 to the power 24 kilogram. The radius of the Earth is 6400 kilometers. R in this case, capital R is 6400 kilometers, is just given to me, and the radius mass of the Earth is also given to me 6 into 10 to the power 24. If you don't know, we just drive when we did mass of the Earth. So 6 into 10 to the power 24, this is given to me, and height is 1000 kilometers. The body is lying at 1000 kilometers from the surface of the Earth. I will add radius plus h, so it will be 7400 kilometers. If I convert into meter, so kilo means 10 is power 3, 10 is power 3 plus 330, so it will be 7.4 in 10 power 6 meter. And you know why we did convert this kilometer into meter? Because SI unit of distance is meter. I use the same formula as we discussed in 5.8 equation. I will use this formula and plug in the values. So value of G is 6.673 into 10 power minus 11 meter square per kilogram square. And you know, mass of the Earth is 6 into 10 power 24, and R plus 8 we just calculated 7.4 into 10 power 6 whole square. Student, you will solve this. If you solve this with the help of the calculator, you will find the value of G at a height 1000 kilometers is 7.3. As you can see, the value as we go up, the value of G decreases. The value of G is depending upon the altitude. More will be the altitude, more will be the lesser will be the value of G. On the surface, you know that on the surface of the Earth, the value of G is 10 meter per second square. But as we away from 1000 kilometers, so as we are at some altitude 1000 kilometers, the value of G is reduced to 7.3 meter per second. As we go up and up, the value of G decreases 7.3. So this is the end of the topic. So 5.2 and 5.3 we discussed today. An example we did today. So students, you solve these numericals, this example by yourself, practice it as much as you can, and write 5.2 topic and 5.3 topic once, and practice it, memorize it again and again, 2-3 times practice it, and then you will become adept in this topic. So if you have any question regarding today's topic, please feel free to ask.